I want to apologize in advance. I'm trying to get over some bronchitis, but for this project, my client wanted a bookcase for her daughter, who is very into cosplay and conventions and very nerdy things. So I came up with a design for her. She's a very big Doctor Who fan, so we designed it such as the TARDIS from Doctor Who. So for the bookcase itself, what I did was it would have two doors that opened up like this, just like the TARDIS, and it would have a decorative rectangular prism, just like the rectangular prism of the bookshelf, on top with the police public call box. Now, these models are not to scale, obviously. So for the bookcase, it would be 60 inches or 5 feet tall and 30 inches across. The width of the bookshelf would be 10 inches. And then for the decorative shelf on top, it was also going to be 30 inches across with 10 inches in the width, but it would only stand 4 inches tall. So to calculate the surface area, I had the equation of 2 times the length and the width times the width and the height and times the height and the length. And I multiplied those by 2 because it is a three-dimensional shape. So if we find the surface area of this side, and this side, we multiply it by 2, we can find the other 3 sides. So for the bookcase itself, we found that it was 5,400 inches squared. And for the decorative shelf, it was 920 inches squared. So the total would be 6,320 inches squared for the surface area. For the volume of the bookcase, we had length times width times height to find the volume. So the volume of the bookcase itself would be 18,000 inches cubed. For the decorative shelf, it would be 1,200 inches cubed. So the total volume of the bookcase would be 19,200 inches cubed. I found this project interesting because I got to pick whatever I wanted as far as interior design, which did not help eliminate any options. I chose this particular design because it's something I personally want, and I think it would be interesting to build, and it's a very basic shape. However, it's got a lot of components in it that I didn't mention, such as the inside shelves and the paint and the width of the doors, etc. But it was interesting because I got to pick from anything, any shape, any particular piece of furniture or decorative design. So I chose something that I'm familiar with, which is something nerdy. As far as using this in my profession, it's definitely going to help teaching my students about measurement, setting up a classroom, things like that. It definitely brings a more visual aspect and more practical aspect to geometry. So it would be interesting to have my students do a project like this, where they can see the practical uses of using volume and surface area, especially for something like a bookcase where you're going to need to know the volume because you're going to fill it with books, presumably. So it was an interesting project. I enjoyed it. I enjoyed getting to look at all the Doctor Who bookcases and figuring out the surface area and the volume. And it all had practical applications, the surface area for the paint and the volume for the books and the weight. So it was definitely a well thought out project with practical applications, real world applications, which is, what the Florida Standard looks for. So I enjoyed it thoroughly.